So you're watching this video because you watched charge and current in a damped system example and you saw me say from this step to this step, magic, and then I did the integration by parts in like one step. I went from here to here. Now there's about 12 lines of working from here to here, I'm guessing, and it's really ugly integration by parts stuff. So in this video, I'm going to do the 12 lines of magic. So if you already know how to do integration by parts, if you think you can get here to here by yourself, you don't need to watch this. Alright, so here we go. We're going to integrate that. It's going to end up at there. We're going to use integration by parts. So we need the integration by parts formula. The integration by parts formula, uv minus the integral of vu dash, and don't forget, with respect to t. Now you've done this one before. You're going to make your life easier if you make cos pi t u. So u equals cos pi t. And it's also going to make your life easier if this is v dash. Negative 2e to the negative 0.1 t. Alright, so that means that u is going to equal negative pi sine pi t, and v will be negative 2 divided by negative 0.1, so 20 e to the negative 0.1 t. Alright, so sub uv in here minus the integral of v u dash. Sub all that in there. Alright, so that's where we'll end up. Now this is a step that you'll forget and it'll make your life harder if you forget it. There are some constants that we can pull out of here. So it's 20 times this times negative pi times this with respect to t. So 20 is a constant, but so is that negative pi. So I can bring the negative pi out, so it's 20 times negative pi, but then I can bring 20 times negative pi outside of here as well. So I'm bringing negative 20 pi outside of the integral. So that'll put my integral here. And when I bring negative 20 pi out of here, because there's a negative there, what I end up with is positive 20 pi. Alright, so done, done. Now we need to do a second integration by parts here. Before I do, let's call this whole thing equation 1, and now let's work just with this bit. Let's get rid of that while we're at it, shall we? That doesn't belong there because I pulled it out. Alright, so nicer. Yep. Now let's... Alright, so we're going to integrate that using our integration by parts formula. Now u is sine pi t, which means that u dash is going to be pi cos pi t. Now v dash is this bit here, which makes it e to the negative 0.1 t, which means that v is going to be negative 10 e to the negative 0.1 t. So I can sub all of that into this, and I'll have a value for this one here. Alright, so I've subbed in my values here, u, v, minus the integral of v, u dash. Now don't forget, you've got a constant out here. This is going to happen all the time. You've got a constant here. You've also got that pi there. So that integral, when that negative 10 comes out, the minus and the minus will come together and we'll end up with a plus 10. The pi will come out, and now we have that integral there. No pi there. Cos pi t with respect to t. Alright, so you should be used to this now. We've got this function here, we've got this function here. We should be able to do some substitution to make this thing work. Because we have a repeated function here. So what happens next always boggles my mind a little bit. We found out that this is equal to all of this. So we can take all of this and sub it back into equation 1. Q is equal to that. So I'm going to rewrite the function Q as being equal to this times all of that. Okay, there we have it. We've just taken this function, written this down again, and then subbed in all of that for that, because that's what we figured it out to be. And now, one last substitution, the sneaky one, because here, e to the negative 0.1t cos pi t with respect to t is very, 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 very similar to what we started with, only there was like a negative 2 out the front. Alright, so we can replace that. That is negative 1/2 of that. So we can replace all of that now with, I'm going to take that 10 pi, and we're going to multiply it by half of q. Negative half of q. And then all of that gets rewritten. Okay, from here, we need to solve this for q, or make q the subject. So we've got a q here, a q here. There's no more integrals left, so really it's just a matter of rearranging. Now we've got all of this to begin with. That can stay where it is. We've got plus 20 times this, so it's going to be 20 pi times all of that, and 20 pi times all of that. Alright, so it's going to be that times that, which is going to be like negative 200 pi e to the negative 0.1 sine pi t, and it's going to be 20 times that, which is going to be like 200 pi squared, but then times negative 1/2, so negative 100 pi squared q. Go! Alright, so that's it. I've just expanded that. So now I have this negative 100 pi squared q. It would be really handy if that q was over here with this q. So I'm going to shift negative 100 pi squared q over to that side, which is going to be plus 100 pi squared q. Then I'm going to factorize out the q, then divide by what's left over, and I should have something to work with. Alright, so I've just got a little bit off screen here, but it says q plus 100 pi squared q equals 20 e to the negative 0.1 t cos pi t minus 2 sine pi t. All I've done is move that there so far. What we need is to take q out as a common factor. So q is going to be 1 plus 100 pi squared equals all of that. Now while I'm at it, I might just factorize this, because we've got a common factor of 20 e to the negative 0.1 t. That gives me cos pi t minus 10 minus 10 sine pi t. And this little bit of factorizing here, I can now move that underneath this, and I'll get 1 plus 100 pi squared. And then, because it was an indefinite integral, I need a plus c on the end. And I moved that down so I can get rid of that now. Which leaves me with q. Okay, that is integration by parts, twice over. Yeah, good luck. I knew I missed something. I lost a pi. 10 pi sine pi t. Yeah.